Hi everyone! We're going to get into lecture Making Sense of It All. So let me tell you why you're here. You have a choice, either a red pill or a blue pill. Just kidding. What I really am going to do though is go over some of the basic things that we've covered over the semester to help you guys start to organize your thoughts and bring it all together to be able to prepare for your final project. So first of all, what is a GIS? So we've learned to think of the world as being made up of physical entities, scientists, researchers, managers of the world. When we take those things and model them in a computer environment, we then are able to answer questions and make decisions. Two things that are important in a GIS. The what. We are also concerned with the properties and the attributes of those features, and the where. We are concerned with both the absolute and relative location of those features. If we were to use a GIS to study vegetation, we could think about the different attributes. So we have our species of vegetation, density, understory or overstory, vegetation class. Those are all attributes. And then we could also think about location. What county, what coordinates are necessary, what state, what area, etc. So as you know, with the GIS, we are able to ask spatially related questions. You guys should be familiar with this process based off of the last discussion exercise. And so I'm going to go over my salamander example again. So maybe I would like to visualize the distribution of my salamanders. And this would be the spatial distribution, analytical theory. So are my salamanders grouped together? Are they more dispersed? Are they all found in a certain bioregion? We can also look at relationship between spatial distribution of objects or themes. Where is X in relationship to Y? Are my salamanders within a certain distance of riparian habitats? And then it takes us into association. And I can ask things like, does water quality affect the distribution of my salamanders? Are salamanders found in wetlands over river watersheds? Things like that. So there are two important components of spatial data, also commonly referred to as a GIS data or geographic data. There is the spatial component, which describes where features are located and how they are shaped or their geometry. And then there's an aspatial component. The aspatial component consists of text and numbers, which are used to describe the attributes of the geographic features, like the name of a school. So again, in simplest terms, a GIS is a spatial database management system. So a DBMS, or database management system, is a software that allows you to store, update, query, and analyze data. This is a program such as Excel or Access, somewhere where you can organize and analyze your data. So a GIS is a spatial DBMS, or a spatial database management system. And so this DBMS has a spatial awareness that allows you to query your data based on location and spatial relationships, as well as by attributes. So here we have a little example. So we could ask, where are all the industrially zoned parcels and agricultural lands within Humboldt County that are located within 200 meters of a large stream and within 300 meters of a wetland habitat? So we're able to use a GIS to be able to answer this question, where we wouldn't be able to answer that question necessarily in just a regular database management system. So again, here we have a Microsoft Access example. It's kind of a smaller picture. So a database management system may contain locational information. It might have coordinates, addresses, and zip codes, but it is spatially unaware. So we wouldn't really be able to ask Access which of these hydrants are located within 30 meters of a school. If we were to pose that same question to ArcMap, which is a GIS program or a spatial database management system, we can then answer these questions with our attribute table data and our locational data. And so we can do a location query and figure out which hydrants are located within 30 meters of a school. We would have a school layer and a hydrant layer, and then we can ask the GIS to figure out those statistics for us. All right, so this also should look familiar to you. So here is a pretty easy flow chart of the GIS process. So first we begin with those questions about the physical world. Okay, so questions should be spatial in nature. Otherwise, we don't really need a GIS, right? We can analyze our data in Excel or Access or SPSS. And so then we get into the planning step. So we need to define our protocols. It's important in large organizations where multiple people are working on the same project. It keeps things consistent about the way that they're doing things. It also is helpful for establishing criteria. So if we were talking about habitat suitability model for yellow-legged frogs, we would want to know what the habitat requirements are. Are they above a certain elevation? We could figure all of that out before we start our GIS analysis. Okay, so then we get to our third step, the collect, create, and edit. And so there's no initial data in a GIS. You have to get it off the internet or from the agency itself. And if it doesn't exist, then you might have to create it. It's one of the most time-consuming things. And so we want to make sure that we give ourselves enough time in the planning process to be able to acquire the data necessary. Okay, so then we get into spatial analysis. And so this is why GIS nerds do what we do. It's fun, addictive, and also frustrating. And for some masochistic reason, we enjoy it. It's like solving a puzzle or just problem solving in general. And so in this course, we just kind of get a small introduction to spatial analysis, but there's really a lot that you can do with just basic data layers that you're getting off the internet. And we'll get into that a little bit later. So the next step is output. And so we need to remember that a GIS will output more for us than just a map. We can get statistical information, charts, and those are just a couple examples of things. We can also create models. And again, we don't really get into too much of that in this course, but hopefully we'll be setting you up to further your geospatial education. Once we're done with our GIS analysis and we've created the outputs that we need, then hopefully it'll help us to decide and act on whatever question we were trying to solve. So GIS can be applied to a wide range of fields. So let's just take a quick look at this application. This would be for making a wildlife decision. So if we were trying to detect presence of the foothill yellow-legged frog, we can cut down on field time and costs if we were able to have a good idea of where to look for different geospatial data. It also can be used to aid in mitigation and restoring habitat for several species of interest. We can see what kind of restoration decisions can be made to maximize positive results for one species while minimizing negative impacts on others. So we're also able to use available spatial data to create a model that ranks location as to suitable habitat for certain species. And like I was getting into a little bit before, models have the potential to streamline future monitoring efforts and assist in creating successful restoration plans with several sensitive species that coexist. All right, I'm going to go over this example. In this slide and the next slide, we're going to be looking at a raster analysis and more specifically a terrain analysis. We didn't really get into this too much in this course, but it's still a good example just to kind of give you guys some ideas. And if you're really interested in terrain analysis, you're more than welcome to reach out and ask for guidance from me. Okay, so the scenario here states a parasitic plant species is increasing in number in the Klamath region. So the question they have posed is, how far could the distribution of the parasitic plant potentially spread? So let's just say that someone has found a dwarf mistletoe that has a very specific habitat requirement, and so we want to be able to establish certain criteria of this parasitic plant. So in the planning process, we're setting these standards. So we know that this parasitic plant prefers dug fir stands within 40 to 49% canopy closure. It likes to be in elevations between 1,000 and 1,400 meters, and most of the time it's found on northeast facing slopes with an aspect of 23 to 68 degrees. Okay, and so when I start thinking about what kind of data I need to gather, I probably need a vegetation layer to look for those dug fir stands. I'll need an elevation layer, so I can look for elevations between 1,000 and 1,400 meters. And I'm going to need an aspect layer so I can look for my northeast facing slopes. So all those slopes will have an aspect of 23 to 68 degrees. Oop. Okay, so here I've got all my different layers that I need. I've got my vegetation layer, I've got my aspect layer, and I've got my elevation layer. And so I'm going to have to select areas meeting the individual criteria. And so I could do different queries. I could use CLIP. I have a few different options of what I need to do. So I'm looking for that dug fir that's between 40 to 49% canopy cover. And so here's my clipped layer here. I need aspect that's just between 23 and 68 degrees. So I've got that altered aspect layer here. And again, I am looking for elevation of 1,000 meters to 1,400 meters. And so I've done my spatial analysis to find where these areas overlap. And I'm going to put them all together to create a nice representation here of potential parasitic plant distribution, which can then be used to help determine where to implement eradication efforts. So here in the red, we are seeing those areas of where that parasitic plant could potentially be. And so you're able to do all of this kind of analysis without even leaving the office, rather than trying to go out into your study area and record every single time you find that particular species of mistletoe. Okay, so all of this just to say location matters. That's why a geographic information system is such a rapidly growing field. Businesses and government agencies need to know where customers and resources are located, how products and services can be delivered most efficiently, and where new facilities should be built. In a rapidly changing world, decision makers in many fields depend on GIS specialists to collect, manage, and analyze spatial data there. And that is what all of you are hopefully working towards by taking this course.